Good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's webinar, Secure Flash Memory in Emerging Electronic Systems, Automotive Markets, Applications, Use Case Scenarios, brought to you by Tech Online, Macronix, ARM, and broadcast by AspenCore. I'm Chris Keach, and I'll be your moderator today. We have just a few brief announcements before we begin. First, the slides will advance automatically throughout the event. You may also download a copy of the slides by clicking on the green folder icon located at the bottom of your screen. You can participate in our Q&A session by asking questions at any time during this webinar. Just type your question into the Q&A text area located to the right of the presentation window and then click the Submit button. Please note that we'll try to get to as many questions as we can in the time that we have left at the end of today's program. However, if we're unable to get to your individual question today, someone will get back to you after the program is over. Also at this time, we recommend that you disable your computer's pop-up blockers, and at the end of the webinar, we will ask you to complete our feedback form. Your feedback will provide us with valuable information on how we can improve future events. You can also launch the survey at any time by clicking on the red survey button at the bottom of your console. And if you're experiencing any technical problems, please type your issue into the Q&A text area, and we will be glad to offer one-on-one assistance. And now, on to the presentation, Secure Flash Memory in Emerging Electronic Systems, Automotive Markets, Applications, Use Case Scenarios. Discussing today's topic are Jim Yastik, Technical Marketing Manager, Macronix, America. Jim is responsible for ecosystem, market, product, and business development at Macronix, America. With 30 years of experience in the high technology sector, his previous roles include engineering, product marketing management, and business development for organizations focused on the semiconductor, communications, and embedded software markets. And joining him today is Andrew Michael Jones, System Architect, Architecture and Technology Group at ARM. Dr. Andrew Jones is the ARM architect focused on the cybersecurity of automotive systems. Andrew is a veteran system architect, having previously worked at the University of Bristol and several microelectronics companies in the UK and the US. It's with great pleasure I now turn this special session over to Jim to begin. Jim, take it away.
Thank you, Chris, and hello, everyone. Welcome to our webinar where we will be talking about the latest automotive trends, how security is being implemented to support these new architectures in terms of features and standards, and how memory is changing to support the storage of secure data. Andrew from ARM, who's a well-known and respected architect in ARM's Architecture and Technology Group, looking at automotive, he will be talking about the emerging automotive architectural trends, security objectives for connected devices, as well as PSA Certified program, which we just received PSA Certified Level 1 certification on our Armor Flash Secure Flash product. I'll finish by going a little deeper into the use cases for Secure Flash, what data is being stored, what features are being added to protect end products, and finishing up with an example of where a Secure Flash is successfully being used. Macronix has been serving the automotive market for many years now, and our business continues to grow due to our inherent strengths. We control our own fabs so that we can implement proprietary wafer lot selection or golden lot strategy, which allows us to identify and select the highest quality lots for automotive. This ability allows us to speak in terms of parts per billion rates now. For our automotive products, we only use test and assembly subcontractors that are fully certified IATF 16949. Macronix is a member of the Automotive Electronics Council, or the AEC Technical Committee, which allows us to be at the forefront of any new and emerging qualification standards. We have a zero defect strategy that ensures automotive products receive optimum attention to detail at every phase of production, including design, wafer fabrication, assembly, and test. And finally, Macronix has ISO 26262 certification, demonstrating its capabilities of supporting the functional safety needs for automotive. Based on our marketing data, We figure we're about number 2 now in the automotive market for NOR flash and quickly moving to the number 1 spot. As you all know, we're currently experiencing exponential growth of connected devices on public IP networks, and that includes all sorts of vehicles on our roads. The global growth in electric vehicles alone is phenomenal, and this growth is bringing about new vehicle architectures and systems that are connected. For example, GM said that they will only be making electric vehicles by 2035. Ford said that all its vehicles sold in Europe would be electric by 2030. And VW said that 70% of its vehicles will be electric by 2030. Aside from these large car makers, many new companies in China, US, and Europe are developing electric consumer as well as commercial vehicles. In addition to electric drivetrain and connectivity, they will have different autonomous driving features. Now, these changes, along with rapid evolution in infrastructure networking markets, are allowing automakers to create increasingly connected vehicles. As more vehicles become connected, the threat of attacks is inevitable. The challenge of protecting valuable assets from theft or maliciousness has forced many organizations to devise secure system architectures. Now, I'd like to hand the presentation off to Andrew at ARM Limited. He's at the forefront of an organization that is the center of these rapidly changing designs in automotive, driving computing and security standards. And with that, over to you, Andrew.
Thank you. My name is Andrew Jones, and I'm the lead system architect for automotive security. I'm going to be talking to you about a security initiative that ARM co-founded called PSA Certified, what it is, and how it can bring value to the automotive sector. ARM has long had a strong presence in automotive, and most of the leading automotive companies make extensive use of ARM's technology. Based on the global volume of vehicles manufactured and the number of automotive products our partners ship, we estimate that the average car built in 2021 contains 18 ARM processors, a number that is expected to increase significantly in the next few years. You can see from the graphic that ARM processors are present in all domains of the car, and we touch most aspects of the electronic supply chain. ARM is aiming to continue to be the key CPU architecture for connected and autonomous vehicles, and we aim to support the ecosystem in moving to the deployment of inherently secure platforms through current automotive trends. It turns out that this is a favorable time to be pushing to standardize secure processing environments in automotive devices. If you review current design trends in cybersecurity and software delivery, you'll find that there's a lot of turbulence in the value chain. OEMs have told us that their next generation architectures will be quite different from current architectures. The increase in software value and complexity has led many OEMs to try to master more of the software ecosystem, as well as leveraging third-party software from other computing domains. This requires the adoption of strong frameworks and standardized interfaces. At the same time, we can see that many silicon providers try to climb up the value chain by providing more services as part of their offering. But the real game changer is that the era of best effort cybersecurity is coming to a close. There are several initiatives which mandate a thorough cybersecurity risk analysis, mitigation, and regulation compliance as part of the vehicle approval cycle. The architecture of automotive vehicles has evolved through several generations whose progression is illustrated here. The approach used by many conventional cars today is one in which functions are partitioned into specialized domains. These sort of architectures will no longer be viable. The automotive industry has responded to previous computer trends by gradually adding more and more ECUs, millions of lines of code, and hundreds of specialized suppliers and parts to the modern vehicle. But this approach seems to have reached its scalability limits. Many OEMs have told us that they are moving to zonal architectures. These are characterized by 4 features. The emergence of an Ethernet backbone, progressing from the CAN bus architecture to a modern high-speed Ethernet communication network. A wiring optimization of ECUs together with new, simpler vehicle network topologies, which can dramatically reduce the requirements for cabling length, weight, and production line cost. Then there is hardware consolidation, aggregating several functions that are today served by separate ECUs into a single, more powerful ECU. And finally, the evolution towards service-oriented architectures that can accommodate the needed flexibility, security, and agility for new software-defined vehicles. The increase in software functionality, coupled with the need to run multiple software stacks, each having no reason to trust each other, on the same ECU compute platform, massively increases the cybersecurity challenge. When time-sensitive and safety-related functions continually require security services, they escalate the need for solid platform security frameworks. This is in addition to CPUs, with hardware support for process and memory isolation, control flow integrity, and crucially, for hardware-protected storage features. ARM was the initial founder of a program called PSA Certified, whose value proposition is based on 3 pillars. ARM security best practices, these include the definition of 10 security goals, a set of architectural requirements needed to deploy secure services, and guidance to create the hardware and firmware which comprise the root of trust. The second pillar provides support for portability of secure software. This comes from a standard framework for secure firmware and a set of widely used functional security APIs which provide abstraction for cryptography, secure storage, and attestation services. And finally, PSA Certified can be used to support vehicle type approval by defining a standardized 3-level laboratory-based audit for chips, software, and devices. The experience from the successful deployment of this approach in IoT was that early adopters aimed for the higher levels as a way of owning the security high ground. Another principal benefit is that the PSA Certified program creates a documented audit trail of best practice from design to certification. Among the key benefits that ARM partners recognize is a reduction in the amount of work in designing, porting, qualifying secure devices in the car. Also, it established an equivalence with several influential standards, so that certifying with PSA encompasses other key guidance. Of course, software will remain the largest attack surface, so to manage the implementation liability risk, it is a good position for partners to be able to certify that they have implemented in accordance with the security recommendations associated with the CPU architecture. The existence of open-source trusted firmware and reference platforms is provided to accelerate the deployment of PSA. Partners can quickly use freely available compliant implementations or are free to develop their own firmware. Let's talk about the scope of PSA Certified. PSA Certified is a framework and certification scheme to ensure that the quality of the root of trust is sufficient to serve as a foundation within connected devices. It specifies requirements and interfaces to allow robust security anchors. It focuses on best practice design of chips, their accompanying firmware, and how they can cooperate securely with trusted subsystems. PSA Certified also specifies the portability of secure firmware and provides that audit trail for managing trust throughout the supply chain that we mentioned earlier. What is not addressed by PSA Certified is the architecture for application software. PSA Certified also doesn't specify a particular implementation, and indeed it doesn't require you to use an ARM CPU. It is architecture agnostic. It is very much focused within the system on chip, and although it supports trustworthy communication, it does not specify any particular protocols which need to be used outside the SoC. As I mentioned, PSA grew out of our work on making secure IoT devices, and as elements which address 4 main parts of producing secure devices. Threat modeling analysis. This is commonly integrated within a secure development lifecycle for the device, and in IoT, PSA Certified offers a set of common threat models which designers can review and adapt to their application. These illustrate the approach that we expect to establish the device's security requirements. There is support for architecting SoCs. PSA Certified includes a number of specifications and guidance for hardware and firmware architecture, and a set of security APIs which embodies best practice design principles. The third part is direct support for implementing platforms. ARM contributes to the Trusted Firmware project, which provides an open source reference implementation of PSA Certified. This firmware has been heavily audited and tested and can be used directly or as an example of how a third party can develop their own. Finally, in Stage 4, along with industry partners, we have defined a certification program where compliance to PSA certified, robustness, and adherence to other security standards can be certified in a way recognized by the industry. This can be used by OEMs to mandate the security quality of platforms made by their suppliers, but also to legally establish platforms as independently verified as best practice designs. It is this management and propagation of trust, from threat modeling through to device certification, which adds much of the value to the ecosystem. PSA Certified is designed to be an independent security evaluation scheme for connected devices. We are currently refining this approach for automotive. The scheme recognizes that there will be different security requirements and different cost security trade-offs for different applications. This is reflected in specifications by introducing a range of assurance levels. The PSA certified scheme involves the evaluation by an independent laboratory of a device against a set of security requirements and, in the case of a successful evaluation, the issuing of a PSA certified certificate by TrustCB, who ordered the scheme. So the evaluation lab examines security measures to ensure that the device, including its critical assets, is not vulnerable to identified threats. Should the device pass, a digital certificate is issued and published on psacertified.org. The certificate number is a globally unique EAN13 number that can be supplied by the lab or the company seeking certification. PSA certified devices support an entity attestation token that can include this EAN13 number that can be used to inform relying parties that the chip, system software, or device has been evaluated and PSA certified. In the IoT space, PSA Certified has been mapped onto several national and international standards and protection profiles, including the cybersecurity standards from ETSI and NIST, so that achieving PSA Certified also qualifies for a number of different standards. In automotive, the intention is to align it with the UNECE World Forum for Harmonization of Vehicle Regulations on Cybersecurity and other standards. The consortium which manages, maintains, and develops these specifications includes ARM with a number of the world's largest evaluation labs. One of the things that laboratories told us was that given the diversity of devices and ECUs used in automotive, without a certification standard for how different devices would present themselves for evaluation, then lab resources could not possibly scale to match demand, and that custom evaluations would inevitably cost much more. PSA Certified uses a 3-level certification scheme to match required assurance against evaluation depth. PSA Certified Level 1 relies on a document and declare questionnaire filled out by the chip vendor and system software vendor or the OEM. The questionnaire covers the baseline security requirements to mitigate common threats and security requirements for PSA Certified products. The evaluation lab relies on this questionnaire to examine the device security measures. In PSA Certified Level 1, there are 3 evaluation scopes: the chip, the system software, and the device. The security evaluation covers the combination of these hardware and software components. The chip evaluation scope includes the following components from the PSA platform: the PSA immutable root of trust, for example the boot ROM, any root parameters, the isolation hardware, and the security lifecycle management; the trusted subsystems used by the PSA root of trust, such as any security subsystems, trusted peripherals, SIMs, secure elements, or secure flash components; PSA updatable root of trust, such as the secure firmware which manages partitions within the root of trust, and generic PSA root of trust services, such as attestation, secure storage, and crypto; and firmware update validation. For the device, the scope includes the following software components. There's the application and libraries developed by the OEM. These may execute in a non-secure processing environment or as an application root of trust services executed in the secure processing environment. And there's the configuration of the system software for the device. Device evaluation relies on an evaluated chip and system software. The evaluation laboratory performs the technical review of questionnaires submitted for PSA Certified Level 1, and, if successful, provides the digital certificate reference number, EAN13, for the scope under evaluation. PSA Certified Level 2 is a classic time-limited white box vulnerability analysis based on a PSA Level 2 protection profile. This takes 25 days of testing and covers software attacks and lightweight hardware attacks. The silicon vendor provides a full functional specification and/or operational guidance explaining how to use the functions and services provided by the target of evaluation, and describing all external interfaces or physical input or output of the target of evaluation. It provides the Level 1 certification material and test results showing that they implemented the PSA functional APIs correctly, together with source code for the components in the scope of the target of evaluation. PSA Certified Level 3 is a fixed-time, test laboratory-based evaluation of the PSA root of trust. This takes 35 man-days for the evaluation, but of course there will be some analysis before that. It is aimed at devices that need to protect against significant and specific hardware and software attacks. The PSA Certified Level 3 documents include a protection profile that describes the target of evaluation, its assets, the security objectives, and security functions that will be evaluated, an evaluation methodology that it details how the evaluation will be carried out, and an attack methods document describing those attacks that are in scope. Developers submit their PSA root of trust to an approved test laboratory listed on www.psacertified.org for PSA Certified Level 3 evaluation and receive an evaluation test report. If the PSA root of trust is assessed as passing and approved by the independent certification body, a digital certificate will be issued on the PSA Certified website. Let's complete this overview by reviewing how PSA might be used in an automotive lifecycle. PSA Certified brings different things to each ecosystem player. The OEM can take advantage of the security quality certification that PSA can provide to the suppliers, and software developers can take advantage of the PSA APIs and secure partitioning to lower the cost of integrating secure software. From the perspective of the silicon vendor, silicon vendors can use PSA certified hardware requirements and guidance to inform their chip designs. They can use the documentation to support their secure development lifecycle. They can port trusted firmware to the platform. They can complete the PSA checklist and can submit it for independent lab examination. Thereafter, the device can be advertised and recognized as PSA certified. From the perspective of the Tier 1, Tier 1s can ask for PSA certified in their RFQs to silicon providers as a security quality requirement. Tier 1 software developers can use the PSA certified framework to implement an additional trusted operating system of their choice, also to implement isolated trusted applications, and to deploy PSA functional APIs to abstract accesses to trusted services. Tier 1s can use PSA certified in their RFQs to Tier 2 software developers to minimize porting effort and to enhance security quality. Tier 1s can use certification to meet the OEM's RFQ. From the perspective of the OEM, OEMs can use PSA certified in their RFQs to Tier 1 suppliers as a quality requirement. OEM software developers can use PSA certified frameworks to support the root of trust software integration and to allow aggregation frameworks such as hypervisors and containers to access secure services. OEMs can also use PSA certified in their RFQs to Tier 2 software developers. In this way, PSA certified can help to build that audit trail of security quality. And finally, OEMs can then use PSA certification to support their automotive type approval process. If you'd like to learn more about ARM in Automotive and PSA Certified, these are some useful links to the PSA Certified and ARM websites. There is also a great report available on the state of security in the IoT ecosystem, which surveyed over 600 tech decision makers in the OEMs late last year. Thank you, and back to you, Jim.
Thank you, Andrew. So why do we need secure flash in automotive? There are a number of main reasons why. Andrew and I have spoken about the rapid growth of new designs around electric vehicles and advanced driver assistance systems, or ADAS development. The features found in ADAS will be provided as a subscription service, so different autonomous levels, features within those levels, and geographical areas will be sold on a subscription basis. This, along with more onboard apps, services, and entertainment in an untrusted connected environment, will require all data related to credentials and keys to be securely stored. In addition, vehicles will be automatically charged for tolls and parking, so financial information will need to be kept safe. The amount of data that needs to be stored securely is growing rapidly, and so are the required densities. So having a strong ecosystem and working closely with partners like ARM and autonomous platform providers like NVIDIA and gaining certification like PSA Certified are critical to ensuring safe storage. So what kinds of specific data are required to be securely stored? Given the use cases I've mentioned for all the services and capabilities that can be purchased, associated keys and credentials will need to be kept safe. Biometrics will be used to enter and operate the vehicle, and that needs storing. Audio and video streaming services will need associated credentials stored securely. Also, financial information needed to automatically pay or authenticate to get the services will need to be kept secure. There will also be a range of personal information like contacts that should be secured. Lastly, secure logging and maintenance data will also need to be safely stored as well. It's always assumed that the details of the cryptographic algorithms are well known by an attacker, so it's only the secrecy of the key that ultimately provides the security. Trying to keep keys secret is one of the toughest challenges in deploying security. Besides the keys, other user-sensitive or private data are usually stored in the same security level as cryptographic keys. In some secure execution environments, a dedicated secure storage is required not only for secret key information, but also for application-specific data. Also, modern operating system architectures that support virtualization or multi-tenancy, it's a requirement to store and support the security credentials of multiple users for multiple applications. For complex systems, this secret information will be stored in external secure flash memories due to the storage size requirements. So the slide here shows a wide range of standard security features that are common in non-volatile memory being offered in the market. They're effective in protecting various threats to its contents. So why would a product need to implement memory with advanced security features? To start with, there's an overabundance of existing designs based on older microprocessors. So if there's a requirement to make the product more secure, it's expensive to do major redesigns of existing products, particularly with complex applications in a hard real-time environment that has been field-proven. If a requirement has come from an organization's marketing department that it must now be connected to an open network, where will the required keys and credentials be securely stored to support secure access? On-chip embedded non-volatile flash memory, it's considered relatively safe if tamper resistance has been implemented. But increasingly, general processors suppliers, they're shrinking the embedded non-volatile memory footprint to only store phase 1 boot code, because as the technology nodes shrink from say 55 nanometers to 28 nanometers, the footprint for embedded flash is much larger compared to the CMOS-based processor and other peripheral logic that has to be shrunk. This is because embedded flash doesn't scale like CMOS-based logic. So 28 nanometers is about the current stopping point. And so expected overall die size and cost reductions fall short. Also, customers have varying density requirements, so betting on any given customer's memory footprint requirements is risky, and the embedded flash adds cost to the product that could be shifted to the customer. There are 3 major advanced security memory products available today, and that Macronix also offers: RPMC, authenticated flash, and a fuller featured secure flash. RPMC is a memory device whose main purpose is to provide sequencing information for signing digital signatures, and also to provide non-volatile monotonic counters for the host to support sequence frames in secure communication protocols like TLS, SSL, to thwart man-in-the-middle attacks. Several memory providers currently offer this type of flash as a dual-purpose memory. This means that there's a region in flash memory reserved for RPMC functionality, with the rest reserved for normal NOR flash. Authenticated flash devices also perform authentication with the host before a secure operation. A good example of this would be the RPMB feature in the Macronix eMMC product. Full-featured secure flash devices perform authentication and encryption along with a full range of additional security features. A good example of a secure flash with advanced security features is the Macronix Armor Flash product. It is a NOR flash device and has many of the standard security features listed on the previous page, as well as advanced security features listed on this slide. At this point, I'd like to properly introduce you to Macronix Armor Flash. I'm going to use it as an example of what a secure flash looks like. It is auto-grade and so AEC Q100 qualified. It's offered in temperature grades required in heat-intensive environments. It meets longevity requirements of greater than 10 years and has security certifications. In particular, our Armor One product has the PSA Certified Level 1 device level qualification, which enables us to show our customers that we've considered a baseline of security. Armor 2 is CAV-P validated and FIPS Level 2 ready. It has a range of security features, as you can see. The crypto components of these devices have been fully vetted and ready for the stringent environments for which they were designed to work in. If you look at its key features, you can see that it has a standard SPI interface. It supports quad mode and octal mode for high performance. It has non-volatile monotonic counters, true random number generator, physically unclonable functions or PUF support, hardware crypto engines, and symmetric and asymmetric key provisioning and management. It is also highly configurable into zones that can operate as either standard SPI or authenticated flash or authenticated and encrypted flash. And in addition to that, these products come with a complete development suite of software and support that enables relatively fast prototyping and development. The software has been ported to a number of environments, operating systems, and chipsets. So I'd like to give you an example of how Armor Flash is used in an automotive application. It is currently designed into NVIDIA's NVIDIA Drive autonomous platforms in a partnership that spans several years. These platforms, if you've kept up with the NVIDIA press releases, are finding its way into a wide variety of new vehicle designs. Many of them are electric vehicles. We are finding that Armor Flash is ideal in the central computer, in telematics, or in infotainment systems. These systems require secure flash storage, and they need a memory that is designed for automotive applications. So they need adherence to ISO 26262 and AEC Q100, certifications like PSA from ARM, high temperature grade, meeting high quality and functional safety requirements. Automotive customers also need performance to meet their instant-on requirements for fast boot. For MCU or domain controllers, it might be more common to find embedded flash with lower required densities to store secure data on chip. Besides Armor Flash, we're having great success with some of our other products in the subsystems shown in the diagram above. I'd like to conclude this presentation by saying that we're in an exciting time in automotive history with the acceleration of electric vehicles and autonomous driving features. This is driving new designs and business models in the commercial space. It is important to remember with security that it has a close relationship with safety, providing a deterministic environment, safe from bad actors. Finally, I'd like to thank Andrew and the partnership we have with ARM and the PSA Certified organization. The PSA Certified Security Framework is a perfect complement to the stringent automotive security requirements, and we're proud to have achieved certification within that program. If you have any further interest, there's an article that goes a bit deeper into memory in automotive, and there's also a link to the PSA Certified organization. Thank you all for attending, and back over to you, Chris, for our Q&A session.
All right, well, thank you, Jim. As a reminder, please fill out the feedback form that will open up at the end of the show. Thank you in advance for filling out the feedback form. Your participation in this survey allows us to better serve you. We're going to now move on to the question and answer portion of our event. As a reminder, if you'd like to participate in our Q&A session, simply type your question into the text box located to the right of the presentation window, or you can click on the Q&A icon at the bottom of your screen, type your question in, and then click the Submit button. Please note that we'll try to get to as many questions as we can in the time that we have left. However, if we're unable to get to your individual question today, someone will get back to you after the program is over. And also joining us for today's Q&A will be Ken Perdue, Automotive Field Applications at Macronix. So, gentlemen, let's get started with some questions for today. Looks like we've got several coming in. Our first one for you is, what are the interface or other requirements to design Armor Flash in? And is there any IP or other functionality that needs to be in place?
Yeah, hi, this is Jim. I can take that question. So the nice thing about Armor Flash is that it can be dropped in. There's no special IP that's required, and that it just really requires software that we can provide. It also has capability to configure it in such a way that it can be just, straight up flash device. So, there's no crypto whatsoever. But then later on, it could be programmed, a particular zone could be programmed to be security oriented, and then at that point, the security protocols would kick in. So, no, it's just a standard SPI interface.
All right, thank you, Jim. We'll move on to another question. This one asks, this product seems useful in non-automotive applications. Do you have products targeting IoT or industrial? For example, do you have industrial-grade products?
Yeah, this is Jim again. I'll go ahead and field this question. So yes, it was designed for these other markets and applications. If you look at if you look at the densities that we provide, like 32 megabit and 64 megabit, they're really the sweet spot for IoT. And again, the nice thing about them is these parts are that they are highly configurable. So if you only need a small amount of secure flash, and the rest you want to be code and to operate at octal speeds, well, then that is available to you. So it's a good part for a dual use application for like IoT. And then also, lastly, we do offer also industrial grade, as opposed to, auto grade, temperature grade. So thank you.
All right, thank you, Jim. We'll move on to our third question for you. I could see this secure flash part used in MCU-based ECUs, where there's lots of data that needs to be securely stored. But what about domain controllers and ECUs where I need to store some things securely, but not that much? I really need it as a dual-use part to mainly store code with a smaller partition to securely store some data. Can Armor Flash be configured for this kind of a use case?
Jim, again, yeah, I'll go ahead and take this one as well. So I kind of answered that question previously, but again, depending on the density, that'll sort of dictate what the zone size will look like. But you can basically configure it so that, for example, on a 32 part, the small zone could be 2 megabits. So you could have a very small area for secure data storage, and the rest could be used as code storage. And then when you're configuring it, it could just be standard SPI flash, and it would operate like that. Or you can program it as an authenticated only, or authenticated and encrypted, so to be highly secure. Thanks.
All right, thank you, Jim. Our next question here asks, what is the current penetration of Armor Flash in automotive and in which applications?
Yeah, I'll field that as well. So I can't talk a lot about that, but I will say that where we're having the greatest success is in automotive, and mostly in ADAS or infotainment systems, where a lot of credentials have to be stored. As I was saying in my presentation, that we have to store a lot of credentials related to Apple CarPlay or Android. I think it's Android car. So in those sort of situations, a lot of credentials and keys have to be stored, but also a lot of information stored just for the system to be secure. So internal credentials between ECU and main computer. So as I say, those are sort of the applications. And then in IoT, I think the edge devices, as well as some high-end IoT type applications. Okay, thanks.
All right. Thank you, Jim. And as a reminder to our audience, if you'd like to ask a question, go ahead and click on the Q&A icon, type your question in, then click the submit button. We'll get to as many questions as we can here in the time that we have left. But right now we're going to move on to another question that's come in. This one says, do you have any software to help support design-in efforts?
Yeah. I'm sure Ken's going to get a chance here to answer a question, but I'll go ahead and field this as well. So we do have a lot of software support that can help you design this part in. So it includes all the drivers that you need, as well as the command interface and supporting the command interface, as well as status commands. And then also we don't provide the crypto libraries, but they're freely available through open source, and so you can get them in that way. And then you can supplant that also with hardware crypto engines on the host. So, and we do provide all that, all the documentation. It's basically our software development kit. Okay, thanks.
All right, thank you, Jim. And another question that's come in, how will PSA certifications help my organization to reduce legal liability?
Yeah, I'll go ahead and take that too. So, I mean, obviously, if you have a third party, like, say, Brightside or any security laboratory that is doing certification, and then that's what they do for a living, then if it's fully vetted by a third party, it's going to reduce the risk. And when you go for any sort of certification, I mean, that's really the advantage that it brings. But also, what's interesting, I think, is that if you need to get, for example, insurance, cybersecurity insurance, which is being sold now, I know that PSA Certified works with these insurance companies to help enable that and lower, the premiums for that. And so that's another big advantage of PSA Certified, of getting that certification, or really any certification. Okay.
All right, thank you, Jim. And we'll move on to another question. What interface and access protocol does Armor Flash support?
So this is Ken. I'll take that question, Chris. So, I mean, the high-level answer, I think Jim's already alluded, is that Armor supports SPI, Quad SPI, and you could say Octobus accesses. The Armor One secure area can be supported by single I/O SPI accesses, while the standard array can be supported by, you could say, single, dual, or quad, single data rate protocols. And the Armor 2 supports the SPI, Quad SPI, and Octa interfaces. And should note the protocols can be completed using single and dual data rates.
All right, thank you, Ken. And we've got another question that's come in. Again, as a reminder to our audience, hold on one second. Just go ahead and click on the Q&A icon, type your question in, click the submit button. We'll get to as many questions as we can. in the time that we have left. If we don't get to your question today, again, someone will get back to you after the program is over. So our next question here, does Armor Flash support flexible output drive strength settings?
So thank you, Chris. This is Ken. I'll take that question. And that is a very good question, and the answer is yes. When we look at the Armor 2, it supports, you could say, a high speed, you could say, accesses, single and dual data rates. And the Armor 2 integrates, you could say, flexible drive strength settings to enable, you could say, the designer to optimize their board level signal integrity. And so the Armor 2 has a configuration register that allows the designer to select one of 8 level output drive strengths.
All right, thank you, Ken. And we'll move on to another question here. Our next question asks, what PSA level is good for Armor Flash, and why is it 1 in the example?
Yeah, I can field that. This is Jim. So really, if you look at a device that doesn't have an MCU on it, doesn't have software per se, then you can just focus on the device level. You don't have to move beyond that. You can achieve a PSA level 2 ready, which we are pursuing. But you know, in general, you just really need the level 1 in the PSA certified program. And so I think, you know, we made a choice, for example, to keep our design simple and effective and cost effective as well. So that's really the highest level certification we need in the PSA certified. But again, we are looking at the level 2 ready.
All right, thank you, Jim. And we'll move on to another question here for you. Does Armor Flash support features which enable designers to achieve functional safety goals?
So Chris, this is Ken. I'll handle that question. As Jim alluded earlier, Macronix has successfully completed the ISO 26262 process certification and is in the process to, you could say, or targeting to complete the, you could say, our multi-IO family product certification this year. And the Armor 2, like our multi-IO family, supports key safety features which enable a designer to achieve their target safety goals. For example, the Armor Flash complete, you could say, read accesses during a safety-related operation and provides correct data. Any corrupt data in the flash would be detected and possibly corrected by the device's internal ECC. In addition, the Armor 2 supports a air information pin, we call it ECS pound, which provides information regarding, you could say, 1-bit air correction and 2-bit air detection back to the MCU or host processor.
All right, well, thank you, Ken. That, let's see here, we've got another question here coming in. This one says, must Armor Flash work with a MCU with security features, or does it also work with general MCUs?
Yeah, Chris, I can field that. This is Jim. I kind of partially answered this question before, but what's nice about Armor Flash is that it can be dropped into a design with no security features, and so it doesn't require it. But obviously, if you have hardware crypto engines, the cryptographic latencies are going to be lower. So you know, they can be very helpful. But the answer, in short, really is that it can work with a general MCU.
All right, thank you, Jim. And that looks like all the time we have for questions for today. Give me one moment here. So I'd like to go ahead and thank Jim and Ken for a great Q&A, and we'll move on here. If we did not get to your question today, someone will get back to you after the program is over. For more information related to today's webinar, please visit any of the resource links available in the green folder icon at the bottom of your screen. And within the next 24 hours, you will receive a personalized follow-up email with details and a link to today's presentation on demand. Once again, we'd like to thank you for attending today's webinar, Secure Flash Memory in Emerging Electronic Systems, Automotive Markets, Applications, Use Case Scenarios, brought to you by Tech Online, Macronix, and ARM. And this webinar is copyright 2021 by AspenCore. The presentation materials are owned by or copyright by Tech Online, Macronix, and ARM, and the individual speakers are solely responsible for their content and opinions. On behalf of our guests, Macronix and ARM, I'm Chris Keach. Once again, we'd like to thank you for joining us, and we hope you have a great day.